Greetings and welcome. In this video we're going to look at factoring quadratics of the form ax squared plus bx plus c. So I'm specifically interested in problems whose leading coefficient is not 1, which is what I'd recorded in the previous video. So this is going to be a slightly trickier type of problem. And I think I can demonstrate it with a quick recall as to why. If I was multiplying 2x plus 3, and let's say x minus 4, when I multiply this out, I'll have, let's see, FOIL it, distribute this one and this one. 2x times x is 2x squared, minus 8x plus 3x minus 12, and then I could combine the like terms of negative 8x and positive 3x, and I would get 2x squared minus 5x minus 12. So what's tricky is this time trying to figure out how to relate these numbers to the original ones up here. So I can figure out how to undo this process and bring it backwards, since factoring would be kind of undistribution, if you will, or writing this as the product of lower degree expressions. Now this 2 came from the product of the coefficients of my x terms, the 2 and the 1. The 12, negative 12 specifically, came from the coefficients of my last terms. But that's not enough. I also need to make sure that this 5 came from some combination, right, of these two things, right? This is where the 5 came from. And where did the negative 8 come from? It was the product of the outsides, and the product of the insides was where the 3x came from. So this negative 5x was really equal to the sum of the OI in the FOIL process, O and I, outers and inners being added together. So it would be kind of difficult to find a relationship that would work out. Now there is technically a guess and check method where I'd know that it's something of this form, some number of x's times some number of x's like this, and you could try to guess and check different combinations, and let's see, factors of 12 are going to be, could be 3 and 4, could be 2 and 6, so I could try it that way, but then I'd also have to try it this way because the 2 with the 1 versus the 2 with the 2 is different, or a 3 here and a 4 here, and a 4 here and a 3 here. And there is a guess and check method that will lead you to the answer. But it's not very reliable. It's not very systematic, and it's kind of a pain that sometimes you even have to figure out, alright, not only do I have to try the different orders, but I also have to consider the signs of those all at the same time. So it can be a little bit tricky. So I'm going to show you a very systematic approach, very algorithmic way to factor ax squared plus bx plus c. And this sometimes may take longer than guess and check, but I guess in some ways it has to do with how lucky you are. But the nice thing about this is it will always lead you to the right answer. And it will also relatively quickly tell you if it is not factorable. So you're not wasting your time guessing and checking every possible combination, only to realize that the problem is not doable. So by the way, this is called the AC method. Specifically from the first step, where I multiply AC, alright, so the first term, last term, and I'm going to find the factors of AC. I guess this could technically be step 2 of AC. Those are my little quotes, that add or subtract to B. and the add or subtract is determined based off of the sign of AC. So if AC multiplies to be a positive number, then we'd find the factors that add. If AC is a product that gives me a negative, then I'd be interested in the ones that subtract to be. Alright, so far nothing too different than our previous factoring method. And now this is where things will diverge a bit, and it will seem confusing at first, but all of the words in this are very particular and needed in order to get the correct answer. So the next step is I will split the b term into two like terms. Let's see, there we are. Whose coefficients are the factors from step 1. Okay, so I'll explain all of this once we get into an example, so some of this language will make sense then. So I'm splitting the b term into two like terms, so the b term is my linear term, so two like terms meaning they will also be linear terms, so in this case they would also be x terms, and their coefficients, or the numbers of those in front of those variables, in front of the x, will be the factors that we found from step 1. Okay, the factors that add or subtract to b. Alright, step 3 technically has its own name. It's called factor by grouping. And it's sometimes used without the AC method. In some cases, it will be used for factoring a four-termed expression. Alright, but here it's going to be a subset of this. So once I've split the b term into two like terms, that would give me the squared term, my two linear terms, and my constant. So that's a total of 4 terms. And factor by grouping, we are going to factor out the GCF, or greatest common factor, from the first two terms comma, and then a separate greatest common factor from the last two terms. Okay, so it's a little bit confusing there, but like I said, in an example, this will all make sense. So I factor it out from the first two terms and the last two terms. And just a note, a nice check to make sure you're on the right track, the two sets of parentheses must match. Alright, so if they don't, that means you've done some error earlier in the problem. And then let's see, step 4 is kind of the conclusion of factor by grouping, where technically we're going to factor out these matching sets of parentheses. But I'll just call it write the factors, I guess. One being the matching set, or you just write one of them, and the second from what remains, or what we factored out. In step 3. Okay, so all these steps are a little bit wordy, but the words are very particular, so they all kind of do matter. And what's nice is, being this specific, they'll be able to apply to a variety of types of problems. So let's see. Let me come up with a problem here for us. So I can walk you through this. So example. So if I was told to factor the following, let's say I had 3x squared. Let's have my last term be positive 4. Let's see. And let's have my middle term be 8x. So I'm kind of making this into a problem that'll work for us. So step 1 said to multiply a and c. So 3 times the 4, AC is going to be positive 12. And now I'm going to find the factors of 12 that add to be 8. Okay? So factors of 12 are 1 and 12, 2 and 6, 3 and 4. Right? And which of these add to be 8? Well, 1 and 12 would add to be 13, 2 and 6 seem to add to be 8, and 3 and 4 would have added to be 7. Alright, so that's step 1. Step 2 was kind of the wordy one, where I split the b term into 2 like terms, meaning they're going to be x terms in this case. So I'll still have the 3x squared, and then I'll have some x term, and then the plus 4 still tagging along here. So I'm splitting the b term into 2 like terms whose coefficients are the numbers we just found, or the factors we just found. So that would be like the 2 and the 6 here. Or technically it could be the 6 and the 2. The order doesn't technically matter. Some people might prefer to put the 6 here because it'll pair up with the 3 maybe nicer, and the 2 here pairs up with the 4. Although, like I said, it won't change our answer, but it will change our work slightly for the process. So 6 and the 2. And then the signs of these will be determined just like in our factoring with a positive 1 coefficient, where since AC was positive, the signs have to be the same. And then we have to kind of look at our next thing is our B term is positive. So if the signs are the same and B is positive, plus plus is the only way I can have 2 numbers that add to be a positive if their signs are the same. So that's the end of step 2. And then step 3 was the factor by grouping, where I just from the first 2 terms take out the greatest common factor. Here would be 3x. And just from the last 2 terms, I'll take out a greatest common factor, which in this case would be 2. And let's see what that would look like. So 3x times what would be this? So that would be x plus 2. And factoring out a 2 here. Don't forget this plus sign. This 2 is positive, so I do need that sign in front of it. 2 times what would have given me this expression? That would have been x plus 2. Let me fix that plus sign. And notice I do have that little verification that my parentheses match, which is important, because my next step, I'm technically GCFing out these entire x plus 2's. I'm stealing it from both of these expressions. Alright? So this would look like x plus 2 times, and then in parentheses what was left over, the 3x and the plus 2. And this is now written as my answer. I've got this original quadratic written as the product, in this case, of 2 binomials. And I could do a quick check if you wanted. And usually if you do a check, I recommend you just check the OI and FOIL, so the outsides and the insides. So x times 2 is 2x, 2 times 3x is 6x, and those add up to be 8x. And is that the same as my original B term? And yes, it in fact is. So that's a good problem right there. Alright, well, thank you so much for watching. So we've got quite a few steps here that will walk you through it, and I'll probably post one more video of just another example with maybe some minus signs in here. Alright, thanks.